I will talk about construction productivity in my talk. I have been studying the topic for 20 years since I graduated from Helsinki School of Economics and slowly transitioned to construction engineering. So you already heard about my multidisciplinary background. But now I will talk about how productivity is also linked to emission goals. Most of the people, when they think about productivity, you think how to do more with less, how to decrease costs, how to compress project durations. But if we think about the building sector in particular, 30% of Finland's emissions are coming from buildings. Out of that, 11% are coming from the construction phase, 43% from materials, and 46% in the use phase. And that's about energy consumption and whatever people do in the buildings and are spending, causing emissions there. The opportunity related to productivity improvement is, first of all, we can decrease the construction durations by 50%. So if a residential construction process today takes 18 months, it's already now possible to do it in 9 months. And what we need is how to scale this, so that all the buildings in Finland would be done in half the time. If we are able to half the time of construction projects, we can decrease 50% of this construction process emissions, because most of them are time-related. In winter time, you need heating temporarily in a building which doesn't have windows. Very carbon inefficient. That's 5.5% of buildings emissions, 1.65% of Finland's emissions. And we already know how that can be done. What we don't know yet and what we are finding out is how to scale it to the whole industry. There are also indirect benefits coming from productivity improvement. Of course, affordable housing is one of them. Everybody's complaining about housing prices in Helsinki. They are not going down, but they are going up. The rents are going up. At the same time, costs are being saved on government level. So if we are able to increase productivity, decrease construction times, there will be more money available that can also be used to decrease that bigger pot, 43%, related to material emissions, because that requires investments. Productivity improvement can make money for those investments. We also know from research that material waste can be decreased, because if you have a smarter process, better productivity, material waste can be decreased by up to 30%. So where's the room for improvement? At the moment, actually, there's a lot. In manufacturing industry, when people are working in the workstation, for example, building cars, they are spending most of their time actually working on the car. But in construction industry, we put helmet cameras. Actually, Chris is back there, doctoral student who did this helmet camera study. And we had 400 hours of camera data, which we classified minute by minute. It turns out that just depending on trade, 15 to 20% of the time is actual installation work. And most of the time is spent on work-related discussions. Of course, people are social beings, so we don't want to eliminate discussions. But there are a lot of discussions that are unnecessary because people don't know what to do. They don't have enough information. The designs are not perfect. So there's a big opportunity in decreasing the amount of discussions that are unnecessary and wasteful by improving planning of the construction process. Then we have a lot of material management related issues. People are moving materials, moving around. They are spending time of waiting. This non-work related actions is mostly waiting because people don't know what to do. So we could quite easily see that this direct work share could double just by having a smarter process in the construction phase without spending too much extra money, but working smarter. We are now exploring many different ways how to do this. And maybe the most scalable things are digital. So although we are examining a lot how to improve the design process, how to increase the amount of prefabrication and so on, I will in this talk focus on the digital situation picture so that everybody knows what's going on, which will directly impact that discussion share of time. And if the computer knows what is going on, then we can also automatically coordinate and send instructions to all the workers in the construction site. So that has been the main focus of our group in the last 5 years. How to collect a lot of data from construction site, including images and videos, use computer vision to analyze them, have IoT, Internet of Things data, calculate the position of all the workers, analyze their movements to figure out where there's room for improvement, and of course all the applications that people are using. There are so many apps in construction site that somebody was saying that every time you add a new app, you should take one away because all the time of the management is spent filling information in apps. That's why we need more automatic data collection. It cannot be people entering information about all their movements into applications. So everywhere where we are trying to do research is how to automatically get data from the process by using data streams coming from different areas. And this kind of real-time situation picture, of course, can be used by artificial intelligence solutions, but it can be used directly by all the stakeholders of the construction process. For example, if you're buying an apartment, maybe it will increase your confidence in the construction company if you can at any time see what's going on in that apartment. Is there somebody working there, or are people, and what kind of quality is being achieved? Afterwards, if there's some maintenance issue, you would go back to the time when that problem was being created and identify the root cause and which materials were used. One way how to automate data collection is the use of robots. So we have done quite a bit of research together with the electrical engineering group using the Spot robot, which is collecting information automatically from construction sites, doing reality capture for real-time construction management. At the moment, Spot is collecting data successfully, but it requires a driver. So it's not really increasing productivity because that driver could be entering information into apps themselves. And also it's decreasing productivity because everybody's coming to take selfies with the robot. So we are now working with the School of Electrical Engineering to automate, make it autonomous. It's collecting data, and based on the data it's collecting, it's calculating in real time that I need to take more data, there's something interesting here. So it's basically taking the design information, these are typically 3D models, and it's comparing it to continuously created map that is creating, and seeing which elements are temporary and which elements will stay in the building. That's how we are able to detect progress, which elements have been constructed, for example, which wall is there. And we can take then pictures about this wall and see whether the wall has been painted and analyze it with computer vision. And we have started from individual trades. We have now worked a lot with drywall, the wall construction and all the phases related to that. But now we are moving to mechanical ducts and cables and so on, and kind of creating different proofs of concepts for different types of work. Another important technology that we are combining then is the indoor positioning technology. I was just today on a construction site wearing helmet and boots, hoping that my clothes don't get dirty, and trying to get volunteers for our study to track their position in real time on construction sites so that we can analyze the process and how many steps are taken. Then when we see where people are moving, we send the robot to see why they are moving, what's the magnet that is pulling people there, and then figure out how can we improve the process so that we move that thing that is pulling people closer to the people, kind of trying to achieve similar kind of setting as in a factory setting. And also we have started discussions with the labor unions and the employer unions that could this in the future be something that all the employees will agree to, so that we can increase productivity, because everybody knows that productivity is also linked to salary levels. And we are making progress, but it's still not at the moment agreed by the labor unions. Once we have all this data, so we have the videos, we have the point clouds, we have analyzed them using computer vision, we have analyzed the movements, then it's time to combine them and go to simulations and actually see how the construction site is working, what is causing the movement, and how can we improve. And then the concept of digital twins comes into play. So we are now working and quite advanced already in the sensing. So we can analyze pictures and we can analyze movements. We can make some analysis of them. The next step is to figure out what kind of simulation model we could use. And we are using agent-based simulation models. Basically, we are modeling every worker and figuring out what causes them to move, and then trying to optimize continuously. How can we decrease movement? How can we increase the share of direct time? And that kind of optimization is critical, because as I said in the beginning, 16% of the time is discussions. Now we want to bring to every worker customized real-time instructions which actually work. The workers are not very fond of management normally, because they give instructions that cannot be done. And our goal is that the computer is able to analyze the situation and give relevant instructions about what can be done at the moment, and something that would work every time. Okay, productivity research would be quite theoretical if we didn't have companies who are actually willing to take this into action. So the last part of the presentation is about social impact and how we're trying to achieve it. We have assembled this kind of Building 2030 consortium, which is 21 companies, and Aalto is leading it. And the companies together want to solve this productivity problem. They also want to increase trustworthiness, because every time construction industry goes to news, we mostly see negative news. But very few people realize that actually in Finland, 95% of the construction schedule projects are finished on time. And a big portion of them are finished without any quality defects, because we only see in the news those problematic projects. So we are doing this kind of benchmarking and measurement. Every year we get data from hundreds of projects, so a sample of all those participating companies and their projects, and we are kind of trying to get a more objective view of what is going on, and are we improving? Are we getting closer to this 50% duration reduction target? And we are at the moment making good steps. So can we actually double productivity? We have case projects where we have achieved 50% duration compression. So from 18 months, it has gone to 9 months with no quality defects, no increase in costs. And that leads to lower carbon emissions. But how to make it scalable, so it's not one project, because that doesn't have any impact on Finland level. How to do it everywhere, all the time. For that, I think we need digital tools. 50% improvement is actually not just, it sounds like a lot, but it has been possible without use of new digital tools, just by managerial interventions. The opportunity is really much higher, but for scalability, we need this kind of new digital tools so that we can have these things benefit everyone in Finland, and of course these results are also useful globally. And we are collaborating many of the world's leading universities to scale this and also learn more from them. So that's the final question that we are working now, how to scale the findings to the whole industry, and what is the limit of improvement where we can go. And we have many group members here. Of course, the group members are doing all the work. The group is in the back over there. Not everybody included, but without them, of course, this work would not be possible. Thank you all.